Hi guys, it's Ms. Miner, and we are going to be working on, lesson 2B. So today's lesson is 2B, and we are going to be solving equations with special cases. And so this is kind of fun. I made this have the sound, special cases. So we're working on three different special cases when we solve equations. And what we have been doing up to until now is solving equations that have one solution. So that's one of our cases that we could have. That's one of the things that we could get when we're solving equations is one solution. That means I'm going to solve this equation and I'm going to get x equals some number at the end. And this is just exactly what we've been doing this whole time in Unit 1, solving equations. These equations that have one solution, that's what we've been working with up till this point, right? So here's our equation, and just to remind you guys of the steps that we need to take in order to solve our one solution equation, remember the very first thing that we always do is we share the love, and that's distributing, right? So you can go back to your Unit 1 notes and take a look. But remember, we're going to distribute. The first thing we always do is distribute. And so we're going to multiply this by 3, and we're going to multiply this by 3. So I end up with 3x minus 3 is equal to 2x plus 9. And once I'm done with that, normally what I would do is have a family reunion. But I can see in this equation, if I look on either side of the equal sign, it's already simplified for me. So I'm all done simplifying my equation, so I can go ahead and start to solve. And the first thing that I want to do when I'm solving is get rid of the extra x's, or remove the x's. And so I'm looking right here, I have x's on both sides of my equals sign, so I need to decide which one I want to get rid of. And so let's just get rid of our 3 x's from over here. I'm going to subtract those off, and I have to subtract from both sides in order to keep the equation equal. This one's going to go to 0, and I'm going to end up with negative 3 equals negative 1x plus 9. And then the next thing I want to do is I want to remove the extra hostage. I want to remove the number that's not connected. So I'm kind of just writing down those procedures that were there. These procedures over here were in our notes for Unit 1, right? So the next thing I want to do then is I want to go ahead and get rid of my extra hostage. I'm going to subtract the 9 from both sides, and this is just review from Unit 1. This is going to go away, and I'm going to get negative 1x is equal to negative 12. And the last thing that I always do is get rid of the number that is connected, my coefficient, and I divide by the negative 1 on both sides. This is going to go to 1, and x is equal to 12. So there is my one solution equation, and that should be review from Unit 1. That is what we have been working with up until this point. So let's take a look at some of our special cases that we can get when we solve equations. One of those special cases is that I could get something where I have infinitely many solutions, an equation with infinitely many solutions. So let's figure out how that works. How am I going to get, what that means is x could literally be any number, and this equation will always be true. So what I'm talking about with true is true statements. This side, no matter what number I put in for x, is always going to equal this side. So let's see how that works. The very first thing I would always want to do when I'm solving an equation, here's the thing, the procedures don't change, okay? So I'm still going to share the love first and have a family reunion in order to simplify. So there's no distributing here, so let's just go ahead and have our family reunion. Over on this side, I have a 2x and a minus x, and they're on the same side of the equal sign, so I can combine those together. 2x's minus an x gives me just 1x on this side, plus 7. And then over here, I'm going to add the 3 and the 4 together, and I get x plus 7 on this side. All right, so the next thing that I would do is I would remove my extra x's, okay? So I have an x on one side of the equal sign and I have an x on the other, so I've got to decide which one of those I want to get rid of. So let's just subtract this x from over here. And this x is going to go away to 0, and all I'm going to be left with is 7. On this side, all of my x's also go away, right? 1x minus 1x is 0 x's. So I get 0 x's over here, right? They go away to 0, and all I have left is my 7 on that side. So what has happened here? Well, this is a weird special case, right? Where something crazy has happened. All of my variables went away, and what I was left with is what we call a true statement. All of my variables went away, and I was left with a true statement. 7 does, in fact, equal 7. And when I get left with a true statement, oh, I'm writing that. I'm state. Is there an extra E in there? I don't know. We're going to put an extra E in there. A true statement. And if I get a true statement, then it doesn't matter what number I put in here for x. I could put a 1, I could put a 3, I could put a 4, whatever number I put in there, my equation is always going to end up being true. So x could literally be any answer. And so for this, I just say x is equal to infinitely many solutions. If I end up with a true statement, my answer is x equals infinitely many solutions. And I just, normally what I do is I say x equals infinite, and I put the infinity sign, and then I say sol, just so that it's shortened, right? And I don't have to write it out every time like the word solutions, right? I just say infinite sol. But what is happening? So let's kind of back up just a little bit so we can kind of just take a look at what is happening here. Let's back up to the very first step that we had, okay? Remember when we first simplified? What did I get when I very first simplified? When I combined 2x with negative x, I got x, 1x, right, plus 7. And then over on this side, I got x plus 7. Here's my true statement again. One side is always equal to the other side. They are the same, right, on both sides. This is the same expression on both sides of the equal sign. So no matter what happens, if I put a 4 in here, right, and I put a 4 in here, then that's going to be true. If I change it and I put a different number in for x, like a 3, that's going to work. So x could equal 3, right? If I put a negative number in here, negative 2, right? No matter what happens, because one side of the equal sign is the same as the other side of the equal sign, because they are not different expressions, then no matter what number I put in there, it's always going to make my equation work. It's always going to make my equation true. It's what we call a true statement, right? And so when I see something like that, then I immediately know that my answer is going to be x equals infinite solutions. Because I could put a decimal number or a fraction in there, right? And no matter what I put in there for x, no matter what that is, it's always going to be the same, and it's always going to be true. All right, so what is the other special case that we're going to work with? Well, here is an example of an equation that has no solution. So let's solve this one and see what happens. First thing I always want to do is distribute and have a family reunion. So here's this. I'm going to distribute my -2. So this is going to get times by a -2, and this is going to get times by a -2. And I'm going to get -2x plus 2 equals -2x plus 5. All right, so now let's go ahead and solve this. The next step that I want to do is I want to get rid of my extra x's. Sorry, let me erase here. I want to get rid of my extra x's, and these procedures are just the same that we've been following this whole time. So I'm going to add 2 x's to both sides. And this is going to go to 0, and I'm going to get a 5 left over. And then look what's happening over here. This is also going to go to 0, but this time what I end up with is 2 equals 5. That's what's left over when all my variables go away. And so what this is, 2 does not equal 5, right? So this is a false statement. And when all my variables go away, and I get a false statement, my variables go to 0, and I get a false statement, there is no number I can put in for x that will ever make this be true. So my answer is x equals no solution. And I just put no soul because I'm a math teacher and I have no soul. That's my favorite answer. That's kind of my little joke that I always tell. Okay, but why are we getting a false statement right here? What is happening? Well, if you look back up here at my equation when I solved it, you'll notice, well, let's rewrite it so that it's really easy to see. When I simplified it, I ended up with -2x minus 2 equal to -2x plus 5. Is there any number that I could put in here for x that would make this be true, right? If I put a 3 in there, right, what's happening is on this side, I have the -2 times x, right? Those are the same. But look at the constants back here. This one I'm minusing 2x from that number, and this one I'm adding 5 to it. Is there any number that is the same when I subtract 2 or add 5, right? So let's say this number comes out, let's say I put a 3 in here for x. Let's just say x is 3, so -2 times 3. This would be a -6, and I'm minusing 2 from it. This would be a -6, and I'm adding 5 from it. And so there's no way that I could take any number and then have it equal to the same thing if I'm subtracting 2 here and adding 5 here, right? If I think of any number, there's no way I could subtract 2 from that number and have it equal to the same number if I add 5 to it. I hope that makes sense. I'm not trying to be confusing. I just want to kind of have you guys think about what's happening here, right? So because of the nature of this equation, where on one side I'm taking a number, the same number, essentially, right? And on one side I'm subtracting 2, and on one side I'm adding 5, there's no way that I could ever make this equation equal, right? This equation is never going to be equal. And so there is no solution that will work. There's no number for x that will ever make this equation a true statement. Okay, so a couple of rules that I want to remind you guys of, okay? And this is kind of the rules that we're going to follow. And if I were you, I'd put these really big in my notes and maybe mark them. If all my variables go to 0, and I have a true statement left over, then my answer is x equals infinite solutions. If all of my variables go to 0, so I get like 0 x's left over, right? And I'm left with a false statement, then x equals no solution. Okay, so there's my two rules. And all of the procedures for solving our equations are the same procedures from Unit 1. We haven't changed like how we're solving equations. We're only changing that sometimes I might get these special cases as a result, and that is okay, all right? One thing that you might want to be careful of is solving, let's see if I have any like that. I don't. Okay. Solving equations where x equals 0. If x equals 0, that's okay. That's a one solution equation. That's not a no solution. I'm talking about when I have 0 x's left. All of my variables go away. So the variable is the thing that has to go to 0, not x equals 0. You'll see a couple of those on your homework assignment today, but if you have questions on it, make sure that you come and see me or email me with any questions that you have, okay? All right, good luck. Have a great day.